Welcome to this explainer. Today, we're decoding a new tool that is literally automating the way we extract and use design systems. If you've ever lost your sanity meticulously inspecting a competitor's website just to figure out what makes it tick visually, well, you're going to want to pay close attention.
So, be honest. Have you ever stared at a beautifully designed competitor's site and thought, man, how hard would it be to reverse engineer all of that? Up until now, reconstructing a layout meant opening up your browser's dev tools, manually copying hexadecimal color values, tracing font stacks, documenting spacing scales, and trying to somehow guess the component states. It was tedious, it was error-prone, and the moment that site updated, poof, all your hard work was completely out of date.
Here's our roadmap for today. First, we'll look at the core design extraction problem. Second, we'll meet DesignLang. Third, we'll peek under the hood at how it actually works. Fourth, we'll dive into its killer Claude Code integration. And finally, we'll wrap up with some real-world applications.
All right, let's jump right into part one, the design extraction problem.
Think about the massive contrast here between the grueling manual grunt work of the past and the automated computed DOM extraction of the future. The old way relied on static source files, like CSS or Sass variables, or maybe Figma exports if you were lucky enough to even have them. But static files don't account for dynamic themes, third-party injections, or runtime overrides. The new way uses automation to act like a real user, rendering the live site to see exactly what the browser sees.
There's a quote from the source material that I absolutely love because it perfectly captures what's happening here. Other tools give you the paint. DesignLang reads the architecture. We aren't just grabbing colors anymore. We're mapping grids, flex containers, and gaps. Most extraction tools just give you a palette, but a design language isn't just colors and fonts, right? It's how those elements structurally relate to one another on the page.
Which brings us to part two, meet DesignLang.
If you take away one thing, it's this single number, 17 plus. Running just one command yields more than 17 structured output files instantly. By simply typing npx DesignLang followed by a URL straight into your terminal, the tool goes to work and automatically populates an output directory with a massive wealth of highly organized design data.
Now, what's incredibly powerful here is the sheer breadth of what you get out of the box. You aren't just getting one generic format. You get drop-in Tailwind themes, W3C standard tokens, and CSS custom properties. It even generates full Figma variable imports for your design team. And this is absolutely crucial for modern workflows, a paste-ready prompt pack for AI coding assistants like V0 and Lovable.
DesignLang goes way beyond a simple color picker. It dives deep into 4 responsive breakpoints, captures hover states, and even assesses the brand's voice and accessibility scores. It programmatically hovers over elements to capture state transitions. It actually reads the mathematical curves of animations to figure out if they feel springy or mechanical. It even categorizes semantic regions on the page like the hero section or pricing table, saving you from having to guess if that shadow is a drop shadow or a box shadow for the 100th time. It is essentially extracting the entire user experience footprint.
Okay, so developers hate magic without mechanics. Let's look at part three, how it actually works.
The extraction pipeline shows exactly how DesignLang pulls this feat off. It specifically caps the extraction at 5,000 DOM elements to ensure it stays efficient, while using Playwright to crawl the live site. It waits for all the fonts to load and the network to idle, ensuring the page is fully rendered. Then, 17 distinct extraction modules jump in to parse, cluster, and deduplicate everything from inline SVGs right down to Z-index layers.
The key takeaway here is that static CSS files kinda lie. They don't always tell the truth. But reading the live computed DOM, that guarantees you capture exactly what the user is seeing. This is the fundamental difference between DesignLang and older style dictionary tools. It treats the deployed live website as the ultimate source of truth.
Let's move to part 4. This is where things get really wild, the Claude Code integration.
By acting as an MCP server, DesignLang bridges the gap between that extracted visual data and your AI coding agent. MCP, or Model Context Protocol, is what allows the AI to securely access local tools and resources. Once registered, DesignLang essentially acts as a highly organized disk-backed database of your extracted design system that Claude Code can talk to natively.
And this setup fundamentally changes your prompt efficiency because it saves you an incredible amount of context window space. If you've ever tried to feed a massive JSON token file into an LLM prompt, you know it eats up context and can completely distract the model. But because DesignLang is an MCP server, Claude only fetches the specific tokens it needs exactly when it needs them.
So your prompt efficiency just skyrocketed. Claude could now surgically request exact spacing tokens or component anatomies without you manually copying and pasting a single thing. You literally just type /extract design and the URL straight into Claude Code. From there, you can ask Claude to build a pricing card using the topography and shadow tokens from that site, and it has all the precise data right at its fingertips. It's like giving your AI an immediate, perfectly documented design system.
Let's bring it all together in Part 5, Real-World Applications.
Whether you're cloning a competitor's visual vocabulary, checking for design drift on your live site, or running an instant accessibility audit, the practical applications for this automated extraction are massive. You could actually hook DesignLang right into your GitHub Actions so that on every pull request, it checks if your checked-in design tokens match what's actually rendering on your staging URL. If they drift, the build fails. And out of the box, it scores all foreground and background color pairs against WCAG standards, even suggesting a remediation palette of the nearest passing colors.
Now, quick reality check. It's important to remember that DesignLang builds the essential foundation and scaffolding, leaving the actual final component generation up to you or your AI agent. It isn't going to write your entire React app for you out of thin air. Instead, it provides the typed React stubs, the variant matrices, and the prompt packs. It gives Claude Code or V0 the exact architectural blueprints they need to generate high-fidelity components for you.
As we wrap up this explainer, I want to leave you pondering a pretty massive shift. When a website's visual architecture is open source by default, what will you build next? We are entering an era where visual execution is no longer a barrier. If you can see it on the web, you can extract its DNA, map it to an MCP server, and have Claude Code build alongside you using that exact same vocabulary. Thanks for joining me on this deep dive into DesignLang, and I'll catch you in the next explainer.